How do we make sure we get the right concrete? How do we get the Dreamcrete? My name is Tyler Lay. I'm a concrete freak, and I want to tell you how to do that today. But my concrete dreamers out there, please subscribe to my YouTube channel so you can continue to get this great concrete content in your inbox. Let's start talking about testing concrete. Did you know the three most commonly used tests in concrete are the slump, are the strength, and are the air content of concrete? And if you look at the years that they were developed, long time ago. The youngest one in the bunch is 1949, about 70 years old. We can do better than this, and that's what this video is all about. I'm talking about performance engineered mixtures and the testing that goes behind performance engineered mixtures. If you don't know what this is, there's a previous video about it, and there'll be more, so keep tuning in. This is summarized in this AASHTO R101 document. Tells you about how to get really great performing concrete. Now, it comes down to two simple things. You have to decide what you need, and you have to use better tests to get better answers. And we're talking about the second one today. You have to run the right test at the right time. Some tests are best done during mix design. Some are best done during quality control. As they're making the concrete, are we making sure they run it right? And then some are best done at acceptance. That's when we say, yep, this is good stuff. I've tested it. I've validated it. That's usually done by an owner or a third-party rep to make sure that this testing is done right. And when jobs that matter, this is the type of stuff that people do. This is a list of a bunch of stuff that experts agreed upon as being important. We're going to talk about each one of them today and the tests that go along with them. Let's start out with workability. Some will say it's the most important because if you don't have workable concrete, then you can't really get anything else. But workability. The slump test is great and all, and it's cool, and it's useful if the slump is between 3 inches and 8 inches. However, though, if we're talking about something that's less than that, something that's for slip forming, like something like a pavement, then that is not useful at all. Below 3 inches, I don't think the slump test is useful. I don't think it tells you anything. What I'm talking about is concrete that looks like this in front of a machine. This is bony, tough to move, hard concrete. That's why you got yourself a machine. And if the concrete is designed right, it comes out looking like this. You don't gotta touch it. It's beautiful. It stands up. It holds an edge. It's consolidated. It's totally amazing. That's the stuff we're dreaming about. That's the stuff we're trying to make happen. If you looked inside a slip form paver and looked at the guts of it, the thing that is the most important thing to consolidate the concrete is the vibrator. We must understand how the concrete responds to vibration. So we decided to try to come up with a test to do that. And we needed something that was simple, that measures the response to vibration, this filling ability of the grout, so it avoids internal voids, and then the ability to hold an edge. This is this cohesiveness, and this is the type of thing you want in slip form applications. So we came up with a test in my lab called the box test. It is a 12-inch by 12-inch by 12-inch box. It has an open top, it has an open bottom, and it's held together by these crazy expensive, not really, like $30 maybe, pipe clamps that are on the side there, to the left, to the right, that temporarily hold that box together. And what you do is, this is now an official AASHTO test method out there. Thank you, AASHTO, for doing that. You add 9.5 inches of unconsolidated concrete to the box. You take a 1-inch diameter stinger vibrator, not a paving vibrator, a handheld vibrator that vibrates at a fixed RPM. You vibrate it in, and as you go down, you count to 3. As you come out, you count to 3. You immediately take those pipe clamps off. You take the edges of the box off, and you say, what does it look like? And you're, yeah, it's gonna hold. It's not gonna move. It's gonna be amazing. But you're looking for honeycombing, voids on the outside, because if there's voids on the outside, there's voids on the inside. And you look for edge slumping. You look for, is it too workable, too wet, that it actually falls down? What am I talking about? Let's see it in action. Here is the vibrator going into the box, right? There is it coming out of the box after it's been consolidated. We take the pipe clamps off, and we take the edges of the edges off, and we get the perfect concrete brownie. brownie. Yum. Oh, it's concrete. Don't eat it. But you're looking on the outsides of it. We're looking for honeycombing, and we're looking for edge slumping. First thing you do is use a visual ranking. You look around at all these things here, and some voids are okay, but we're okay with between 10 to 30% surface voids, and that would be a rank of 2. So the test method has pictures in it like this. You hold them up, you look at all 4 sides, you rank all 4 sides, you average all 4 sides, and you say, is it about a 2 or so? And that gives you an idea if it's going to pave. You also can measure the edge slumping, use a straight edge. We say we went less than a 1/4 inch edge slumping. Sometimes there's bottom edge slumping. Sometimes there's top edge slumping. And there are 2 pictures there. One on the left is straight. Look at that, perfect, amazing. And one on the right, it's kind of bending over a little bit at the top there. You got the green lines in there to show that it's not a good mix, right? We need forms to kind of hold that sucker in place. So the box test examines this window of workability for concrete pavement mixtures. It's not too workable, it's not too dry, somewhere in the middle. How does it respond to vibration? But there's another test out there called the VKelly, developed by my good friend Peter Taylor at Iowa State. And how that test works is you have a little trough underneath it that you put concrete in, then you drop that little weight at the top, the metal ball, and you see kind of how far it drops in. Use that measuring scale at the top to see how far did it fall into the concrete. And this is called the Kelly ball. It's been around since the 1950s. It's been used in the state of California. And they think it's comparable, gives you some insight into slump for very, very low slump concrete. So Peter's using that Kelly ball already, that shape and that weight as the basis for his test. But then what he does is he amps it up a little bit, just like Peter does. You turn on the vibrator, and it starts shaking, and it drops that ball further into the concrete. And you measure basically how far it sinks over time. And it's pretty simple. You run the test over 36 seconds at 8,000 vibrations per minute, and you record the depth into the concrete every 6 seconds. You plot that, and the slope is called the VKelly index, and it gives you some idea about the workability of the concrete. And these tools, again, are crazy helpful during the mix design stage. Doesn't necessarily need to be used other places, but they're very, very helpful while you're designing a mix. So what do you do if there's problems with workability? Well, one thing you should do is look at your aggregate gradation. And an amazing tool out there that I developed is called the tarantula curve. And it looks something like this. This is where you plot your sieve size down here. Larger sieves, smaller sieves. On the y-axis, you have your percent retained. So you plot that inside here. But that's not enough. There's more. You also have to plot the coarse sand, that's between the 8 and the 30, and then you have to plot the fine sand, that's between the 30 and the number 200. And some people say, well, isn't the tarantula only for slip forming? No, it used to be, but then we extended it. This does slip forming. It also has limits here for flowable concrete, and all the other limits are the same. Why is it called a tarantula? Because it looks like a tarantula. I know, in your nightmares now, forever, right? And if you want to find out more, you can find it at tarantulacurve.com, or there's videos, a bunch of videos. I have example problems. I have free spreadsheets at tylerley.com/tarantula videos if you want to learn more. But what do you do else if it's not tarantula problems? It's not an aggregate problem. Well, it may be a paste content problem. You may have too much paste in your mix. It may be your admixture choice and dosage, and you have to be careful with the amount of water that's in your concrete. And thank you for watching this video about Dreamcrete. Again, as always, like, subscribe, leave me a comment, and check me out on Instagram and Facebook at concrete.tyler. Take care, my freaks. See ya!